I'm Anil Kumar sharing with you 8 questions on related rate of change. It is a huge application of calculus. Now we have questions in which two quantities are linked with time. We have to develop equation to link them, and then finding derivatives we can find the rate of change of a required quantity with respect to the other at any instance of time. You may require a few formulas to solve these questions. One is the distance formula. Let me write that down. Distance formula d will be given as square root of x minus x1 whole square plus y minus y1 whole square. Now at times you can also use square of a distance. Now that could be helpful. So you could also use distance square as x minus x1 whole square plus y minus y1 whole square. So you could use distance square. Now most of the time we'll be doing implicit differentiation, right? We'll do it is difficult to do implicit differentiation. So most of the time we'll be doing implicit differentiation. So if we have to differentiate this particular equation, let us say let's say d square equals to x square plus y square, then its derivative with respect to time will be 2 times d dd over dt equals to 2 times x dx over dt plus 2 times y dy over dt, correct? So that is implicit differentiation. You might also use few formulas. For example, in these we are talking about distance between aircraft and beacon changing, that is this formula. Rate of change of ladder, so there'll be a right angle triangle where that distance formula can be used. Rate of change of shadow is kind of similar. Rate of change of height in water in a cylinder. So if you are working with cylinder, you may use volume. Volume for a cylinder is pi r square h, right? So that is for cylinder. And then we have, this is also cylinder. Cone, volume for a cone is 1/3 of that of the cylinder, 1/3 pi r square h. So that's the volume for a cone. Trapezoid. So for a trapezoid, the two sides, let me sketch one here. Okay, so we may have a trapezoid which could be kind of like this. So the opposite sides are parallel, and if these sides are A and B with height in between as h, then area of cross section will be A plus B times height divided by 2. And now when we talk about a trough where it could be of length L, right? So that is the area of cross section. So let's say if we have some water being kept in this kind of a thing of length L, it gets multiplied by length to get the volume, correct? So that is for trapezoid. Okay, so that is again the distance formula, speed, distance, height. So you know, distance is speed into time. So in the examples which I'm going to take, we are going to use these formulas. Now let's take these examples. All of them are multiple choice questions. I'd like you to copy the questions, do them, and then check with my solution. So here is the first question on related rate of change. An aircraft is flying horizontally at a speed of 600 kilometers per hour. How fast is the distance between the aircraft and a radio beacon increasing 1 minute after the aircraft passes 5 kilometers directly over the beacon? So let us first sketch a diagram and then we'll relate these two parameters. One is the speed at which the aircraft is flying, which is given to us as 600 kilometers per hour, and that is horizontal, kind of like this, right? Now let us say that the beacon is right here at this point. Then with time, the distance is increasing. We have to find rate of change of this distance, right? Let's call this distance as S. The height is fixed. So the height is given to us as 5 kilometers. Let me write 5 kilometers here. Since the speed is 600 kilometers per hour, that means the distance traveled will be 600 times t, right? Now this is a right triangle. So in this triangle, we can relate the separation between the beacon B and the airplane A with Pythagorean theorem, right? So we could write this as S square is equal to 5 square plus 600t whole square. Now this is the only example where I'll be writing what S is in terms of t and then implicitly defining the relation for others, but here we will be explicitly writing equation in terms of time for separation S. So it could be written as square root of, so 5 square is 25 plus 6 square is 36, 2 zeros, 2 more, t square, square root. So we get a relation explicitly of separation with respect to time. Now to find rate of change, we'll just take the derivative here with respect to time. So ds dt is equal to half of, all this comes in the denominator, which is 25 plus 36, 4 zeros, 1, 2, 3, 4, t square. Derivative of this in the numerator, which is 2 times 36, 4 zeros, t, right? So that is the rate of change of separation. We have to calculate this 1 minute after the aircraft passes. So time is 1 minute. 1 minute means 1 over 60 hours, right? Because the units are kilometers per hour. So 1 minute is 1 over 60 hours. That is the time. At this time, we have to find the separation. So we can say ds dt for t equals to 1 over 60th of an hour is how much? We can simplify this a bit, cancelling 2. And now we can substitute 1 over 60 for time. So we get 36, 4 zeros, times 1 over 60 over square root of 25 plus 36, 1, 2, 3, 4 times 1 over 60 square, right? So that is, we could write here. 60 square means 60 times 60, okay. So that's what we get, right? Now we can use calculator to simplify and get the answer. We could write this as, let's do a bit of it. Let's say 0. So 6 goes 6,000 we get in the numerator. So we have 6,000 divided by square root of 25 plus, here we get 36, so 100. So we get 100 here. So the answer here is equal to 6,000 divided by square root of 125. Okay. Now we are given, well, so we can actually rearrange this. We can write this as 6,000, 25 times 5 is 125. So we could write this as 5 square root 5. Since we have two terms with square root on the numerator, let's rationalize it with square root 5. So So that is rationalization. That gives you, that becomes 5 times 5, 25. So let's use the calculator. So 6,000 divided by 25, we have times square root 5. Is it okay? So 6,000 divided by 25 is, I wrote 600. It is 240, right? So 240 square root 5. Okay. So that is the answer. 240 square root 5 is the answer for this separation, rate of separation, and the units will be kilometers per hour. Correct? Now let's move on and take the next question. We have 8 examples like this. A 6-meter ladder leans against a building. The foot of the ladder is pulled away from the building at a rate of 0.8 meters per second. How fast is the top of the ladder falling when the foot is 3 meters away from the building? So we'll use this base to sketch. Let us say this is the ladder, right? Of course, this portion is the ladder, not that. It is 6 meters. Let us say this is x, this is y. So we can relate x square plus y square is equal to 6 square. So that becomes our equation. We are given that this ladder is being pulled at the rate of 0.8 meters per second. This is the x direction. So we change in x with respect to time is given to us as 0.8 meters per second. How fast is the top? So as it is pulled, this will come down. So this is falling, right? How it will go down. So we expect a negative answer. How fast is the top of the ladder falling when the foot is 3 meters away? So we need to find dy dt when x is equal to 3, right? When x is equal to 3. So let's find the derivative of this expression with respect to time. So what we get here is 2x dx dt plus 2y dy dt is equal to 0. We want to find dy dt, so we can isolate, right? So we get 2 and 2 can cancel. Let me do it later. 2y dy dt is equals to minus 2x dx dt, or we can say dy dt is equals to minus 2x over 2y times dx dt, correct? So that gives you the value as negative x over y times dx dt. Now we need to find the rate of change of y with respect to time when x is equals to 3. So when x is equals to 3, we also want to know what y is, right? So we can find the value of y from this equation. So y is equal to, let's do it here. When x is equals to 3, we'll substitute 3 here. So we get y square equals to 6 square is 36 minus 3 square, which is 9, right? So that is 27. So y is equals to square root of 27, correct? So when x is equals to 3, in that case, it is 6 square minus 3 square, so it is square root of 27. So that is what y is. So let's substitute this value. So we have minus, x is 3 for us, y is square root of 27, and dx dt is given to us as 0.8. So let's multiply and get the answer. So it is of course negative as expected. So we have 3 times 0.8 divided by square root of 27, which is equal to, let's see decimal value, 0.461, correct? So the closest is A, which is minus 0.46 meters per second, right? Okay, so that is the answer for, and it is clearly coming downwards since that negative indicates this, right? So let's move on and do the next question. A spotlight on the ground shines on a wall 10 meters away. A man 2 meters tall walks from the spotlight towards the wall at a speed of 1.2 meters per second. How fast is his shadow on the wall decreasing when he is 3 meters from the wall, right? So let's sketch the diagram. Let us say the spotlight is at this position and the wall is right there. Let's say this is the wall. So the shadow is actually on the wall, right? So this is, let's say this line indicates the shadow of a person who is walking. So this is the person who is walking, right? The height of the person is given to us as 2 meters. And let us assume that the person is x meters away from the spotlight. The total distance is 10 meters. So this is 10 minus x, right? That is 10 minus x. Let y be the height of the shadow. Now, whenever you have this kind of a situation, we can relate x and y with similar triangles, correct? So if you look at the bigger triangle, then we get y over the whole length, which is 10. So the equation is y over 10 is equal to, bigger triangle, right? Y over big triangle 10. Small triangle 2 over x is equals to 2 over x. So that is how y and x are related, correct? So we could write this as y is equals to 20 cross multiply 20 over x. Okay. Now we can differentiate with respect to time both sides. So what we get here is dy dt is equal to minus 20 over x square, right? Minus 20 over x square dx dt. We need to find dy dt when x is 3 meters from the wall. That means if it is 3 meters from the wall, that is this distance is 3 meters. In that case, what is x? X is going to be 7. Do you see that? So let us write down the conditions here. So what we have here is x is equals to 10 minus 3, which is 7. This is important to understand. 3 meters from the wall. And y will be equal to 20 over 7. Right? Anyway, here we are given dx dt as person is walking with the speed of 1.2 meters per second. 1.2 meters per second. Right. So let's substitute these values and calculate. So we have dy dt when x is equal to 7 is minus 20 over 7 square times 1.2. So that becomes the answer, right? So it gives us 24 over 7 square is 49, right? So that becomes the answer, which is minus 24 over 49 meters per second. Now in the question it says, how fast is the shadow on the wall decreasing? The negative value here means decreasing. And therefore you don't see negative in the answer. How fast is it decreasing? It is decreasing at the rate of 24 over 49 meters per second. So option A is the right option. Correct? So now let's see the next question. The question here is, a cylindrical tank with a height of 15 meters and diameter 2 meters is being filled with gasoline at the rate of 500 liters per minute. At what rate is the level of the tank rising? So we have a cylindrical tank. So when it is cylindrical tank, radius remains constant. So you treat radius as a constant, not a variable. Correct? So in this particular situation, we have height of 15 meters. This is 15 meters. And diameter of 2. So diameter of 2 means radius of 1 meter, correct? is being filled with gasoline at a rate of 500 liters per minute. So that means volume, right? Liters per minute, rate of change of volume is 500 liters per minute. Now the answer is in centimeters. So we have to convert this unit into centimeter, that is cubic centimeter. So 1 liter is actually equal to 1000 centimeter cube. And therefore, we could write this as equal to 500 times 1000. So 500,000 centimeter cube per minute. Right? That becomes dV dt. So rate at which water is being filled into this tank, right? So that is what it is. So when you do that, the water level will rise. So we need to find rate at which the tank is being rising. So this height is changing, correct? So we have to find rate of change of height. For a cylinder, what is volume? Volume is area of the base pi r square times height. So rate of change of volume dV dt is equal to pi r square. Radius is not going to change, right? It is treated as constant, times derivative of height with time dh dt, correct? We need to find dh dt. Let's isolate this, or we can actually substitute the values. It's better to isolate. So from here we can say dh dt, that is rate of change of height, is equal to 1 over pi r square times dV dt, right? So radius is in meters. It is good to convert this also in centimeters. So what we have here is, that is dV dt, and the radius is 1 meter, which is 100 centimeters, correct? So we'll substitute this value here and then calculate. So let's do it on this side. So we have dH dt is equal to 1 over pi times r square, which is 100 square, times dV dt, which is 500,000. 500,000, right? So this is 4 zeros. So 4 zeros can be cancelled. Let's do that. 1, 2, 3, 4. So 100 square vanishes. So what you get here is 50 over pi, correct? So 50 over pi is option A. So that becomes the answer for this particular question, correct? So I hope there is no difficulty in understanding these questions. Let's move on. And now we have another interesting question. It says, the trunk of a tree is approximately cylindrical in shape and has diameter of 1 meter when the height is 15 meters, right? So let's say that's the tree. Now we have diameter of 1 meter in this particular case. Let's say 1 meter is the diameter at some instance of time, and the height is 15 meters. Okay. If the radius is increasing at the rate of 0.003 meters per second, so in this case radius is also changing because it is growing, right? So dr dt is equal to 0.003 meters per year. Okay. If the radius is increasing at the rate of 0.003 meters per year and the height is increasing, that means dh dt is 0.4 meters per year. Determine the rate of increase in volume of the tree. So we want to find dV dt of this, correct? So that's the question for us. Well, we know cylindrical is the shape, and therefore volume is equals to pi r square h. Now in this case both are changing with time. Do you see that? So we can write dV dt as equal to, r is variable, so we have to differentiate it like a product rule, correct? So we can take pi constant, and inside we'll apply the product rule. So it is 2 times r dr dt times h plus derivative of h this time, so r square dh dt. So that becomes our equation. Is it okay? Now what is radius? Radius is equal to, let me write down here. We need to find this, of course. The radius is given to us as 0.5 meters, correct? And height is 15. Height is 15 meters. We can substitute all these values now and find the rate at which volume is changing, correct? So dv dt is equal to pi times 2r, that means twice, radius is 0.5, that becomes 1. dr dt is 0.003 times height, which is 15, right? Plus r square means 0.5 square times dh dt, which is 0.4. Right? So let's calculate all this. So we have pi within brackets 2 times 0.5 times 0.003 times 15 plus 0.5 square times 0.4 bracket close equal to. So we get our answer as 29 over 200 pi. Now the choices are in decimals, so we'll just find decimal equivalent of this, which is equal to 0.455, something like this. Let's continue. We'll add our option E, which is 0.46 meter cube per year, right? So I think there's some typing error here. And let's move on to the next question. The question here is, a tank in the form of a right circular cone with altitude of 6 meter and base of radius 3 meter is being filled with water at a rate of 4,000 liters per minute. How fast is the surface of the water rising when the depth is 3 meters? So let's make a cone here first. And let's say that is the center. So that's the cone for us. Now in this cone, we are given that the height of the cone is 6 meters. So this height is total is 6 meters. And the radius is 3 meters. Radius is 3 meters. Right. Now we have to find the rate at which water is being filled. So let's say at any time water is at this height. So let's call this as the radius r and height h. Now you can see the similar triangles in a cone. That is how you can relate all your equations. So similar triangle is always to be used for a cone. So we know height over radius is equal to 6 over 3. Since we need to find the rate of change of height, we'll write what radius is in terms of height. So that is 2. So in that case, we know half of the height is equals to the radius. So that's the relation. The volume is given to us as the formula for cone. Volume is 1/3 of pi r square h. Now writing r as h over 2, we get the equation in terms of height. So 1 over 3 pi, r is half of h whole square times 2. That gives us 1 by 3 pi h square by 4 times h, or we can write this as pi over 12 h cube, correct? So that becomes the relation for volume. Now we can easily find rate of change with respect to time. So we get dv over dt as equal to 3 pi h square over 12 dh dt, correct? Which you could simplify this as pi h square dh dt over 4, correct? 3 pi, 3 cancels. We need to find how fast is the surface of the water rising when the depth is 3 meters. That means we need to find dv dt when height is equals to 3 meters. Now, we need to find dh dt, rate of change of height, when the height is 3 meters. So at that time, what is r equals to? So if height is 3, in that case, radius is going to be, so if height equals to 3, then radius is equals to 3 by 2. Is it okay? So when height is 3, radius is 3 by 2. So in this formula, well, we don't have radius, so we don't have to figure this out anyway. So let's rewrite this equation as dh dt is equal to what? So we have dh dt equals to 4 over pi h square times dv dt. Now we can substitute 3 for h and find our answer. So we get 4 over pi times 3 square, and dv dt is given to us as 4000 liters per minute. Now we have to convert this liters to meters. Well, the answer is in minutes or in seconds, I'm not very sure of. But first we'll just do liters, meters per minute, and then figure out. There could be typing error. So when we say, let's do it on the side. So let's convert the units. 4,000 liters per minute is actually equals to 4 meter cube per minute. Is it okay? That is the conversion factor. Right? 1 meter cube is equals to 1000 liters. Right. So dv dt is 4 for us. So we'll write 4 for dv dt. So what we get here is 16 over 9 pi as our answer. However, the units are meter over minute, not second. Is it okay? So there is another typing error here. This is not seconds but minutes. So sorry for these typing errors, but I hope you understand the method and how to do it, correct? So our option is option A, which is 16 over 9 pi meters per minute. So that is a typing error. Excuse me for that. But I hope the method is understandable, right? So that's how we should be doing it. Now let's move on to the next question. This is a very important question from test point of view. The question is, a horizontal trough 12 feet long has a vertical cross section in the shape of a trapezoid. The bottom is 3 feet wide and the sides are inclined to the vertical at an angle whose sine is 4 over 5. Given that the water is poured at 10 feet cube per minute, how fast is the water level rising at the instant the water is 2 feet deep? So let us first sketch the trapezoid. So trapezoid is a figure which is kind of like this. And here we are given that the base is 3 feet. So this is 3 feet. We are also given that this inclination angle. So let me just make this kind of triangle portion here. Okay. So this inclination is basically, okay, so let me do it here itself, right? So this inclination basically is in the ratio of 4:5 for sine. So this is theta, the vertical angle. So the ratio is 4:5. That means if this side is x, 4x, then this is 5x, right? So that is what it means. So if this side is 4x, this will be 5x. So what will be the height? So we actually will have a triangle, right triangle. Let me draw it here once again. We'll have a right triangle whose ratios will be kind of like this. for angle theta, this is 4 over 5. Then the other side is going to be 5 square minus 4 square square root, which is 3. So it is a 3, 4, 5 right triangle, where height and the side x are in the ratio of 4:3. You get the idea, right? So what we're trying to say here is that if this dimension is x, then, and that is height, then the ratio of height to x will be 3:4. That's what it means. Perfect. So tan theta is 4/3, right? So we can say tan theta is 4/3. So that gives you the relation between height and this value x, correct? Now that helps us to solve this. So let me complete the drawing here. So we have cross section of a trapezoid and it is 12 feet long. So let me just extend it like this, right? So, and this length is 12 feet long. So now we can actually write down the formula for volume. Volume for a trapezoid will be area of this cross section. Area is half of sum of these two sides, which is x plus 3 plus x plus 3. Sum of these two sides times height times the length, which is 12. So that becomes the volume of this particular trapezoid. Now we also know from here that x can be written in terms of height. So this gives you x as equal to 4/3 times height, right? Now, so volume is equals to, now here we have 2x plus 2 3's. So when you do half of it, we get x plus 3, right? So we get x plus 3 times 12h. Replacing x with 4/3h plus 3, and then we'll open this, right? We have 12h. That's the volume. So the volume can be now written as, open the bracket, so we get 16h square plus 36h. So that becomes the volume in terms of height of this trapezoid. Correct? Now we can always differentiate this particular expression with respect to time to get rate of change of height for the rate of change of volume. So we can now get dv dt as equal to, derivative is 32 बंद कर दें. So dv dt will be 32h plus 36 dh dt, right? So dh dt. So from here we can isolate dh dt. So we get dh dt as equal to 1 over 32h plus 36 dv dt. Now we need to find water level rising at the instant when the water is 2 feet deep. That means when height is 2. So we're looking for h of 2 feet, and this time rate of change of volume is given to us as equal to 10 feet cube per minute, right? So let's substitute this value to find the required rate of change in height. So dh dt when h equals to 2 will be equal to 1 over 32 times 2 plus 36 times 10. So that gives us 10 over 100, which is 1 over 10, right? Feet per minute. Perfect. So option A is the right option for us. So that is how it can be solved. For what values of x is the rate of increase of x cube minus 5x squared plus 5x plus 8 is twice the rate of increase of x? There are 4 choices given to you. You can pause and answer the question. Here is the solution. We should write this equation as y equals to x cube minus 5x squared plus 5x plus 8. Now if we differentiate both sides with respect to t, we get dy dt equals to 3x squared minus 10x plus 5, all this times dx dt, right? The question is, for what values of x is the rate of increase of this, that means y value, is twice the rate of increase of x? That is to say, we have to find when dy by dt is twice dx by dt. Dx by dt. This is what we have to find, correct? So now from this equation, if I replace dy by dt by 2 dx by dt, I can find what x is. So replacing dy by dt by twice dx dt, we get 3x squared minus 10x plus 5 times dx dt, right? Now dx dt cancels, and we have one equation which can be solved easily, which is a quadratic equation. So we could now write this as 0 equals to 3x squared minus 10x plus 5 minus 2, or 0 equals to 3x squared minus 10x plus 3. Now 3 times 3 is 9, so we could write this as 3x squared minus 9x minus x. So we are writing minus 10s minus 9x minus x plus 3. And we can now factor this. Taking 3x common, we get x minus 3 here. Taking minus common, we get x minus 3, right? So that gives you two factors, which are x minus 3. So take x minus 3 common. So you get 3x minus 1 equals to 0. Now, so we get two different values of x, which is x can be equal to 3 or x can be equal to 1 over 3. So there are two solutions, and option C is the right option, right? So that is how it can be solved. The last question here is, two cyclists depart at the same time from a starting point along the routes that make an angle of 60 degrees with each other. How fast are the two cyclists moving apart after 2 hours if they are traveling at the speed of 15 kilometers per hour and 20 kilometers per hour respectively? 4 choices are given to you. So let us sketch the diagram. So we have two cyclists. Let us say one is going along this direction. The other one is going along a direction which is at 60 degrees. So let's say that is the other direction, correct? 60 degrees. Let us say that the cyclist which is moving horizontally is going with the speed of 20 kilometers per hour. So let me write 20t here over time. And 15 kilometers per hour is the speed of the other one. So we'll write 15t on the other side. Now the separation between them is this distance, right? So that is the separation. So let me indicate that with letter S. Now we need to find how fast are the two cyclists moving apart after 2 hours, right? So we can actually use cosine law here. We know this angle here is 60 degrees, The angle is 60 degrees. So we can write S as equal to square of these two, sum of squares of these two, which is 15t whole square plus 20t whole square minus 2 times product of these two, 15t times 20t times cos of angle between them, which is 60 degrees. Perfect. This is square of this separation. Now we can actually calculate this out. So 15, let's use 15 square is equal to 225. So we have 225 t square plus 400 t square minus 2 times 15 times 20, 600 times cos 60. Cos 60 is half, so we get 300 t square, right? So combining these terms, which is 225 plus 400 minus 300 equals to 325 t square, correct? So s square is equal to 325 t square, so we can write what s is equal to. So s is equals to square root of 325 t square, which is t times square root of 325, correct? Differentiate with respect to time, so we get ds dt as equal to root of 325, correct? After 2 hours. So after 2 hours, it is going to be the same thing, which is square root of 325, since it is independent of time. So let's calculate this answer. Square root of 325 is equal to 5 square root 13. So that gives us 5 square root of 13, right? Since it is independent of time, so we get our answer as A, which is 5 square root of 13 kilometers per hour, right? So that is how it could be done. Now remember, this is the cosine law which we applied here to find the solution. If you are given two sides with inscribed angle, you can always find the third side using cosine law. So that helped us to find an easy solution to this particular question. I hope that helps. So this series was basically meant to review all about related rates, and I hope you got a good practice. Feel free to make suggestions, and if you like and subscribe, that'll be great. Thank you and all the best.